Hi, my name's Jason Barcham. I'm an associate partner with Servian, New Zealand. Welcome to the Technology Whisperers, a technology and innovation podcast brought to you by Servian with your hosts Alistair Ross and Sean Muller. Join us as we demystify the latest emerging innovative technologies for businesses of all shapes and sizes, sharing our thoughts on how you can improve your current technologies, practices and processes to transform your business.
Welcome back to the Technology Whisperers. Alistair Ross and I, Sean Muller, are today going to be talking about a subject that's near and dear to my heart, machine learning operations, or MLOps, or model ops, depending on who you're talking to and what vendor you're talking to, that have different titles for them. Alistair, I know AI/ML is not your jam, so I really appreciate you joining me for this episode. That's giving you an out.
Yeah. Look, it's there are so many wonderful things in this world of IT, right? That's the thing. You have to choose your discipline, and
absolutely.
And I think that, over the years, certain things have taken me down certain highways, and the highway for you, Sean, has certainly taken you towards ML, AI, and all that wonderful stuff. So I'm really in a position here of being the layperson. And I'll put my hands up to say that I don't know much about this situation. But the great thing about that is that I guess that puts us in a good position for us to have an honest and open conversation about, where we can be in a situation where there's one of us that doesn't know a lot, and then there's somebody who knows an awful lot about it, and I can ask the dumb questions and not get too frightened about it.
well, no. So, and I think that actually aligns really well to what we're trying to do with this podcast, right?
It does.
So if we can demystify what MLOps is and why it's different, or what's important about it, or model ops, or whatever you want to call it, I think that if we can boil it down to something that's consumable and easy for someone who hasn't done AI/ML before, I think we've actually succeeded in doing something that's very important to the industry. So
yeah, absolutely. So, I memean, one of the things that really strikes me is that, everybody talks about data and how important that is. And I hate that. It's just one of these things. It's like people say to me, digital transformation. I'm ready to get them with a pitchfork, right? It's right. But ML is something which really is taking the world by storm. And it is something that we should all be paying a lot more attention to. And so maybe if you could just start by taking us down the journey of what ML is and where it's come from and why all of a sudden it's become so popular.
Yeah, absolutely. I think that's actually a brilliant place to start. And I'm going to use some definitions that I use on a regular basis when I talk to people about AI/ML. They're framing ways of looking at it, and there are a lot of people that are going to disagree with me because I try and use simple framing mechanisms to be able to talk about it. Because especially on the business side, I get a lot of, well, what's the difference between AI and so for me, the framing function is that artificial intelligence is some kind of function that provides a outcome, whether it's a chatbot that can talk to you, whether it's and I won't say the A word because she's sitting behind me. When you go to talk to the Alex thing, that's an AI. A machine learning model is the model that sits behind that can over time become better. And what I mean by that is as data is fed to it, as interactions are fed to the machine learning model, over time it gets better and better and better. So the first time you say a sentence to a machine learning model, it might understand one or two words in it. By 2 or 3 months down the road, it might understand the context of the full sentence and be able to provide you some feedback on it. And that's in my mind, structurally, functionally, that's the difference between AI and ML. So AI is the consumption portion of it. ML is the machine learning model that sits behind it that has to learn and grow and get better and better and better.
So back in the day, do you remember in the 1980s? I mean, really back in the day, do you remember a thing called ELIZA?
Yes.
And
Absolutely.
Eliza, I mean, was not AI,
No,
but
no.
if you kind of think about it, it was a chat bot of sorts that you would have a psychology conversation.
Yes,
So we could call it pseudo AI, and
yes,
then
yes.
if you've ever used Eliza or something like that, you could have a one-way a two-way conversation with
Yeah,
this thing, but it never learned. It never got any better. And
that's
if it
right.
had ML in the back of it, is what you're
It
saying
would have
is
gotten
it
better.
better, it would understand you as an individual, it would start to
That's
make the
right.
conversation more
That's
realistic.
right. That's right. So, and Alistair, you've hit it perfectly. So the AI is the function. It could be backed by an algorithm. It could be backed by a tier, like Eliza was, a tier of conversation responses. Like it basically, you would say, yeah, I went driving in my car today. A tier, like Eliza was, a tier of conversation responses. Like it basically, you would say, yeah, I went driving in my car today. And Eliza would go, well, how did that make you feel? But it was a canned response, but it's an artificial intelligence function. It's artificially pretending to be intelligent. It's not machine learning driven. And so as we move forward into the 90s, there are people building machine learning models. And in fact, at a university level, we saw machine learning models being developed. And in fact, and I apologize about my terrible American accent and pronunciation of New Zealand places, but Waikato University created some of the first software to do machine learning model development. And this was in the 90s. Fast forward to the 2000s.
Waikato.
Yes, I know. But my 5-year-old has begun correcting my pronunciations of it, and I try so hard. So fast forward into the 2000s, and machine learning models and deep neural networks are starting to show real outcomes at the university level. The challenge is that you don't know if you're going to be able to build a successful machine learning model until you try and build it. So in the early 2000s, for you to do an experiment, you have to buy a rack of servers and put them in your data center, probably spend, $750,000 to run an experiment. It's not going to happen in business. So we go forward about 15 years. So we're now into the 2000 teens. Cloud has become a thing. Now businesses can start experimenting for hundreds of dollars or a couple $1,000. They can stand up a machine learning experiment in the cloud, run it for a month or two, see if they can get value out of it, and then turn it off. That has been the magic moment for machine learning and why it's so big now. So a lot of the mechanisms that we have, and don't get me wrong, we've made a lot of progression in machine learning model development in the last 15, 20 years. And they're better and better and better. They're getting better all the time. We do it better, smarter, faster because we can experiment in the cloud for smaller amounts of money. The cloud has really allowed businesses to test to see if machine learning models can provide them any outcome. And to your point around data, Alistair, we didn't know that the data was bad or was not usable enough for machine learning models till we started doing experiments and exploration with the data and the machine learning models. So until we got cloud and had, subscription based consumable compute services, we couldn't even tell. And it was really interesting in the 2000, probably 2015, 2016, when GPUs became very, very big within cloud services. GPUs was a turning point for machine learning models because deep neural networks require GPUs or TPUs. Has to do with TensorFlow, but they need those GPUs. They can't do it in a CPU. They need something that is designed to process a lot of data really, really, really fast for the deep neural networks to actually work. And so having racks of, or access to racks of GPUs in cloud meant that I could run an experiment, spend, $10,000 running an experiment for a month to see if it was going to be valuable and not have to go buy $2 or $3 million worth of GPU servers to see if I can get value for my business out of it. And that's really why it's becoming such a big thing, because businesses can now see if it's successful. And what they're finding is these models are helping them fundamentally transform the way they do their business.
Excellent. All right. So we'll come back to that particular part about why it's fundamentally transforming businesses. I think because
Yeah.
that's a really, really important point, right? But MLOps, right? So you've described what AI is,
Yeah.
and you've described what machine learning is. But what's MLOps? What's that all about?
So let's pull this apart a little bit. Let's start with so people on the pod listening to the podcast might not know what DevOps is. If we look at software development, the idea with DevOps, or you'll hear the term CI/CD pipelines, is that a software developer can write a piece of code, can check that piece of code in, and automatically the code will deploy into a development environment and allow the developer to look at the code and see how it's running. And if it's good enough, he can request that it get merged into a test environment where automatic tests are run against it. And assuming it passes all the tests, he can request that it be merged into production. And so essentially, you have this rapid automated move from a software developer and potentially multiple software developers working on the same piece of code, right? I mean, that's the idea behind DevOps is that we build a pipeline that automatically takes it all the way to production while still assuring the security viability of it, the testing capability, quality assurance, all the things that need to be done. And it's integrated into the wider enterprise. So identity mechanisms are controlled around it, service management, all those things are controlled around it. That's, I mean, when we talk about DevOps, that's what we're talking about, right?
Yeah, it includes the infrastructure as well, doesn't it? So
That's right.
all of like you had teams of people who were doing sort of like the traditional IT team that were doing
Yep.
the infrastructure, the servers, the storage, the networks, all that good stuff. And then obviously you had the developers, and the two would never talk back
That's
in the
right.
day, right?
Yeah.
And DevOps is supposed to be, and to
Brought
some
them
extent
together.
brought them together.
Yeah.
So you have the IT people who you call ops, and the developers over there, dev, and bring
Yeah.
them together in DevOps.
Yeah, and so in the DevOps, in the old days, the software developer, if he needed a server to deploy his software on in development, he'd open up a service ticket or he'd call the help desk, and 2 weeks later, he'd have some kind of server that he could install his software on, and of course, he'd find that there weren't drivers installed on it, and it caused a big mess. DevOps is a way of automating that so that the request for the development environment to build the software on is just automatically provided for him, and the operations people, the infrastructure people, see what's coming, can size things, they can put code in. So that's DevOps. At the most fundamental level, there is a problem with machine learning model development. That fundamental level is that currently today, if you have a data scientist that knows how to code or write the architecture around a machine learning model, in about 6 to 9 months, them working on their laptop with the data, they can make you a machine learning model that gives you the outcome that you're looking for from that data. So let's shorter if the outcome is easier. Let's imagine it's just a prediction engine. You have all the sales figures you have for your company for the last 10 years. You give all those sales figures to the data scientist, and he builds a machine learning, or she builds a machine learning model that looks at all that sales data and predicts what your sales are going to be next week. You could probably build that machine model in, I don't know, probably a month or two. And depending on the data scientist, depending on how they build it, they're going to build it on their laptop in a Jupyter notebook, a Python Jupyter notebook, and might cost you, I don't know, maybe $100,000. And you have a working model that you can give it any date or any week in the year, and it gives you a prediction of what you're going to sell, like quantities that you're going to sell. Then you decide, okay, well, I want all my salespeople to have access to that. Well, I can't give them the data science laptop. So I have to deploy this model somewhere where the sales team can access it. So you make copies of the Jupyter notebook, and you make copies of the data that's used to feed it, and you try and get all of them to run on all of the sales team's laptops. Well, that doesn't work. That's a big mess. Data scientists know how to work Jupyter notebooks, sales teams don't. So now you need to somehow containerize that Jupyter notebook or the function that that Jupyter notebook provides and build some kind of API so that the sales team can just go to a website and could type that in. What we're finding is to go from the data scientist's laptop to that we have a containerized machine learning model that has a web front end that can be queried to do that is up to 3 years.
And why is it currently at a situation where it's taking so long? What are the reasons for that?
Well, so part of it is the way the data scientists work. So within their Jupyter notebooks, data scientists are used to working in notebooks where everything is all in one little block. They typically, they're like software developers. They typically don't put any comments or any kind of documentation around what they're building. So there's not a good indication of how and why it works the way it works. The being able to monitor the model becomes important because as a model learns, it gets better and better and better until the day it doesn't. What we found is that machine learning models tend to skew or drift. And what that means is let's imagine that a model is 90% accurate and it runs for 3 to 6 months and then it suddenly drops to 30% accuracy. Now, the reason that happens is a lot of it has to do with the way the data is fed into it. Imagine the Facebook chatbot that became sexist and racist in like the space of 2 or 3 days of interaction with the public. That's a skew or drift. We don't want the machine learning model to skew and drift based on the interaction that is happening. The second thing is that containerizing that model so it can run becomes very complicated and difficult unless you have all of the pieces around it. So unless you have the API structures to be able to query the model, you have a way to monitor the model, you have some kind of function that deals with the model if it goes south, you have a versioning mechanism. Versioning. Versioning is really interesting. Software versioning is fairly simple. It's not very complex, even for multiple software developers working on the same model, on the same piece of software. A machine learning model has the model architecture, the model hyperparameters. So within the architecture, what is the most important thing? And then the training data. So you could change any one of those three without changing the other two. And technically, the entire model version has changed. You could not change any of the architecture, not change any of the hyperparameters, but feed the machine learning model new training data, and it's a different model with a different outcome. So versioning and tracking versioning of machine learning models is much threefold more complicated than software. And we do know that tracking software versioning is one of those things that DevOps has started to do really well, but it's still a complicated subject, right? Version tracking of software development is still difficult.
Yeah, so basically, how's this for an analogy then? So in software development, traditionally, when you update some code and you push it, that's a software version, right? It's a change in the version, right? What I guess you're saying is if the ML part was analogous to just somebody working on a spreadsheet in the back office somewhere, and they update a value in a cell of that spreadsheet, that is a version update in the
That's
ML
correct.
world, right?
That's correct.
So that's much more nuanced, much harder to track.
That's correct. And in fact, semantic versioning, the major minor bug or major minor issue way that we do versioning within software is much more difficult to do within machine learning because do you change? Is it a major change if you just retrain the model using new training data? Or is it a minor change? Or if we suddenly go from, so there are different libraries for machine learning models, right? So there are TensorFlow libraries and there are XGBoost libraries and there are scikit-learn libraries. So if I've built a machine learning model using a scikit-learn library, and then I've identified 3 months on that there's a TensorFlow library that works better for it, and I re-architect the entire model, still the same data input, still the same software outcome, but I've changed the entire library that I'm using. It's like going from, so you go from an Angular JavaScript application to a React JavaScript application. That's a major change within the versioning of that piece of software. the same in machine learning model. I've now changed the entire architecture of how I build that model. But, a month on from the new TensorFlow model, I might go in and change some of the parameters. So just like one line of code, that might be a minor change within the model development. But yeah, so tracking all of that and how you progress that and how you test that and validate the security of the Python code is easy. The quality assurance of the Python code is easy. How effective the model is much more difficult to test. So how you bake that in to do quality assurance testing, so MLOps is us essentially building a CI/CD pipeline that allows us to use programmatic ways that we use software development DevOps to move a model from experiment to development to test to production. And the complication difference between DevOps and MLOps is having to deal with all these different aspects of training a model, because the final code isn't the code the software wrote, the software engineer or the data scientist wrote. The final code is that code that they wrote run through a sausage factory of data and generates an output piece of software. You can't write a machine learning model from hand. There's no way. You have to feed it data. That's why they're effective. So feeding them data or training the software with the model, training the software model with the data is how you end up with a usable product at the end. And here's the scary thing from a DevOps perspective. You can actually train the model twice using the same exact data, using the same exact architecture, and you might get a slightly different outcome.
Spooky.
Yeah. Well, so and when we look at the way data science, this is not a knock on data scientists. I love data scientists. We work with several of them. They're brilliant people. They see things that nobody else can see. But the reality is the data scientists are where software developers were in like the early 2000s. They put stuff in their code that they then comment out. They use the same variable over and over and over again through their code. Their coding practices are terrible. And to make it worse, most of them work within a Jupyter notebook, which is Python code embedded inside a markdown notebook file. So they run it inside and it generates graphical interfaces, graphical outcomes inside their notebook file. And if they check that into a Git repository and then they run it again and the graph changes slightly, Git thinks it's a different version because it's markdown language. So the code that generates that image has changed. So how we deal with that from a versioning perspective, especially when they're doing experiments, is very difficult. And what's happening is that there are a lot of models that are in production today that the original data scientist is no longer at the company, and the company is hard. They don't understand why the data scientist made the decision to do the things the way they did. There's no documentation, and they can't reverse engineer it because the notebook is messy.
So basically, coming back to the start, then MLOps is really trying to do what we did with Dev and Ops, putting them together to make DevOps, to add automation, to remove ambiguities, to streamline the whole development operations process. So we're doing that for the machine language development process.
That's right, and we're doing it in such a way to help the data scientists, because let's be honest, most data scientists don't want to do the coding part. They're data scientists. They want to look at the data and they want to look at the outcome. They do enough Python coding to get themselves to where they're going. But if we can simplify that and allow them to consume it and get better outcomes, I mean, most of the data scientists I talk to don't even want to learn Git. They just want to write code, enough code within the Jupyter notebook to get them what they want. And they want to push a button and just have it go through and run the testing and come back and tell them. It's why AutoML in Google Cloud and in Microsoft Azure is so hugely powerful, because AutoML is basically MLOps without you doing anything. You just basically hand the data to them and they run it through a series of algorithms They identify which hyperparameters make the best sense. They identify which model library makes the best sense. And then they give you a black box at the end, but you can't go backwards with it. You can't go back and say, well, let's move this hyperparameter here. Let's change this architecture there. Let's use new training data, because it's kind of a little bit of a black box.
Okay. All right. So let's talk about the end result then. So to your average sort of CEO who's maybe like a CEO who's got a lot of data to deal with, but maybe isn't really doesn't really know about how to deal with it in a smarter way. Let's just say, for example's sake, we've got a CEO. I'm the CEO of a food a food chain, right? A supply, a food chain supply. So I've got lots of data about perishable foods.
Yep.
I've got data about suppliers, their reliability, about who's going to buy on what day, about all that sort of stuff. But that's just data. It's just sitting there in a warehouse, and I'm not actually making that much of that data. What can you do with MLOps, all as a combination there, and perhaps some AI as well? What sort of outcomes would you say? Obviously, not as a salesperson, but what would the benefits be to the organization that would be thinking about what can I do with my data to make it better for me?
Yeah. So it's a really good question. And speaking of salespeople, I have a lot of salespeople in our organization that come back to me and say, "Hey, I'm talking to clients, and they say they want to do AI ML, but they say they don't have time to do it." And I think it's I don't think it's a time thing necessarily. I think it's a they don't know where to start thing. And your question is exactly that. Where do they start? I have all this stuff. I know I want to do AI ML. I'm looking at Amazon. I'm looking at Netflix. I'm looking at Spotify, and I see these companies getting massive benefits, but I don't understand how they're getting massive benefits from machine learning. I don't know where to start. I have all this data. This is where a senior data scientist comes in. And I had a professor in an AI engineering course that I took that this is the way they described it. The difference between a senior data scientist and a junior data scientist is business knowledge. So a junior data scientist can write Python code. If they're given the data, they can write Python code to do data exploration, and they can generate machine learning models to answer questions. A senior data scientist can talk with the business and identify what it is the business is trying to accomplish, and can help them go back and look at their data to see if something is interesting there. The reality is that these businesses actually know, or they know what value they could get out of their data if they just understood what their data was. So let's say the example that I've used, and I've used it on a couple podcasts. I had a discussion with a dairy owner. And for those of you not in New Zealand, a dairy is a convenience store or a 7-Eleven or a Quickie Mart or whatever it is. So I happened to have a conversation with him, and I mentioned the fact that I worked in AI ML, and he got all excited. This is a sole proprietorship, runs his own dairy. And he said, yeah, gig economy. I read this article in Forbes, said that I had to look at machine learning models and that they could help me. I reached out and found a machine learning model data scientist guy from India, and I spent about $10,000 with him. And I now have a working model that tells me how much stock I need to order on a week by week basis. And that model has reduced the amount of overage that I have to keep in stock
Cool.
by 50%. And he's actually been able to add another refrigerator into his dairy because now he doesn't have to have that stock area anymore. And he's not, because previously, and this is so from a business perspective, right? He had been in the business for like 50 years. He'd owned this dairy. He got it from like his father, right? So he has institutional knowledge of how to run a dairy. And so week on week, he goes, well, my gut tells me I need to order this and this. I need to order 2 cases of Coke, and I need to order, 12 cases of ice cream. And, we're coming to summer, so I got to double the ice cream order. His gut tells him to do that based on his years and years of experience running a dairy, right?
Right.
What the model did was it gave him confidence that he was doing it right, or it gave him a different perspective that allowed him to adjust that, because his gut tells him, well, we sell out ice creams in summer. The machine learning model looked at it and said, yeah, I know it feels like that, but actually order a case and a half. Don't order 2 cases. And a case and a half was enough. And he still had overage if the kids from the local school came in and bought a whole bunch of ice cream. And so it it didn't the machine learning model didn't take that decision making process away from him. It provided him additional information. And by the way, all the business people are currently doing this. They're using Google. If they use Google search to look for something, they're using a machine learning model to answer a question. And I know that the business people they're going, they're typing into Google, should I be talking to a consultant about digital transformation? Which you and I both hate that term, but they're typing that into Google, and it's coming back with a whole series of articles that give them answers on that question. They're already using a machine learning model. So if they have data about their business, about their suppliers, about their customers, there are use cases that a senior data scientist can come in and work with them to prioritize which one makes best sense. The ones that roll right off the top of your tongue are workforce management. So retail companies have been using workforce management tools for years and years and years and years and years. Contact centers, help desks have been using workforce management tools. They're okay, but not great. Machine learning model driven workforce management tools are head and shoulders better. So the example that I had was there was a retail clothing store that was using a workforce management tool based on receipts. So the receipts would tell them that on a Tuesday afternoon, they sold this many things, so that there were this many customers in there. So they needed to staff that retail customer with, say 2 employees. What they couldn't see is that there were 10 customers that came in and didn't get helped by the workers, and so they ended up not buying something and left. So a machine learning model that looks at the security cameras and says, hey, it's not 2 people buying stuff, it's 12 people potentially buying stuff, and you're leaving 10 people's worth of sales on the table that you're not consuming. So workforce management is great. Sales prediction, stock predictions, the entire financial account space has room for machine learning. And by the way, the accountants have been using algorithms. The insurance companies have been using algorithms for years and years and years. The machine learning models just allow those algorithms to be better. So at the experiment phase, there is value to a data scientist coming in and helping identify prioritized use cases that a business might be able to get a value or an outcome at, and they can do experiments. The MLOps allows you to, once you've identified a model that the experiment is interesting and looks like it has a good outcome, you can progress that rapidly to production in a way that the entire company can use it.
And make it reusable, right?
That's right.
So,
Yeah.
even if you hired a data scientist for, a couple of months to do the initial model, then you wouldn't have to have them around forever.
That's right.
Because you have something which is generally reusable, or you could hire that data scientist back in every now and again when they needs a little tweak
That's right.
here and there.
That's right.
But you've
And
got
so
that factory, like you
that's right.
said.
So let's touch on the one thing about I mentioned skew and drift. So with software development, once we go into production, unless there's a bug in the software, we don't touch that software anymore, right? I mean, yeah, okay. Operating systems and libraries get bugs, and so sometimes we have to touch the software. But unless we want a new feature, we don't generally touch that software, right? Machine learning models, that's not the case. Once you productionize a machine learning model, over time, it will skew or drift. So it might go from 90% down to 30% and become an unusable model. So you have to constantly be watching and querying that model to see what its current effectiveness is. And then you need to be able to automate the process of redeploying the model back to its good effectiveness. And so if you don't include that, there's a company that we have worked with in the past that has used a machine learning model that they commissioned a data scientist to build several years ago. Eventually, the skew and drift happened, and the model stopped working, but the data scientist doesn't work for them anymore. So They've had to throw the whole model away. So they spent the time and the money to build the model. And they used it for several years very effectively, much better than a spreadsheet, much better than a database. Skews and drifts. They don't have an MLOps pipeline. They have no way to deal with that model. They've just gone back to spreadsheet because they don't know what else to do. The MLOps pipeline allows you to get true value over a long period of time out of those models.
Okay, gotcha. All right. And then talking about, earlier on you mentioned how the economies of scale brought to us by the cloud have really made using ML and therefore MLOps a reality for businesses that are not, huge in size, because the investment was just outweighing the benefit back in the 90s and the noughties. So those platforms that we have in the cloud, what are the more popular platforms that we use today?
Yeah, so that's a good question. So I will tell you, one of the indications, if you're a business and you aren't thinking about AI ML, what you need to understand is the largest, most successful companies in the world, Alphabet, Microsoft, AWS. This is so important to them. They have built platforms. So they have not only AI ML platforms, but they have built MLOps platforms. And, Alistair, that Servian is, we're a big cloud company. We do work on AWS, we do work on Azure, we do work on Google. So we're across the spectrum. And each one of them, so in AWS, SageMaker 2 has an MLOps architecture that you could do in Azure, Microsoft Cognitive Services, and they have a entire machine learning development studio, and they have an MLOps architecture. And one of the leading AI ML companies in the world, Google, has an MLOps platform. It used to be called AI, the AI platform. It's now called VertexAI. VertexAI became a generally available product in August last year. We did an implementation at Servian in New Zealand on VertexAI last year, and the idea is that it's a managed service platform. So they have, similar to the way that cloud platforms do databases as a service, they have a AI pipeline as a service. They have an AI monitor or machine learning pipeline as a service. They have a machine learning monitor as a service. They even have auto ML baked into it, so the data scientists can write all their code to test their machine learning model, and they can write a single line of code that says, and run my data against auto ML and compare it to the model that I just created.
But does that mean that they can start building out, the data scientists, that when I say they can start building out their code rather than on a local laptop with the Jupyter notebook? They can actually write it right on that cloud platform?
That's right. That's absolutely right. And it gives them a nice graphical web interface to go in, and they can look at all of the, so when they do experiments, right, they're running on their local laptop. And I've written a couple models that literally took 3 days for the model to train. So I started it and went away, and 3 days later I came back. My laptop was unusable for that time. And I know lots of data scientists that do that. Running it in the cloud changes that. So managed notebooks sitting in Google Cloud, they can start it up and run it inside the Vertex pipeline using cloud resources, and they can take their laptop and they can go do something else. Maybe they're doing data exploration. Maybe they're working on 2 or 3 different models, and one of them is data exploration. They can play around with that on their local machine while their model is training in the cloud, and then they get a notification that says, hey, your model's done training. Here's the report that says how effective the model is based on the data you've given us.
Awesome. So it really is a quantum leap for AI ML.
Yeah. And we can version it in the cloud in such a way that we can compare. We ran it this way this time. 2 days later, we changed something and ran it this way. Here's the difference between the two. And that's something that data scientists really struggle to do, that in any kind of way that allows them to, if they make changes in the model, it's very difficult for them to go backwards and undo those changes unless they've saved a previous version. And
all right,
the pipeline to do that.
Very cool. All right. Well, I think that's all my dumb questions asked. Is there anything that you think that the audience probably still need to know about AI ML?
No, I think that Alistair, I think you have done a spectacular job asking all the right questions. The direction, I mean, the things you were trying to get out of it, I think, is the things that businesses are trying to get out of it and what they struggle with to understand. I could, you know, I think this is the direction that a lot of software is going, and a lot of my impression is in the next 5 to 10 years, every application will have some element of ML built into it. Now, whether that's just providing a recommendation engine on the top of something or it's chatbot enabling a web interface, I think that we're going to see that. But yeah, this is you're right. This is the quantum leap is probably the right word. This is the
Mm.
next iteration of the value that we're going to be getting out of applications.
Yeah, well, the next thing I was going to say is that, we're on the cusp of quantum computing as well. And when quantum computing comes along, that will be another massive step because these things are very computationally intensive right now. And
Yeah.
even running them in the cloud, you have to submit this data to the cloud. It
Yep.
goes off, it crunches the numbers for you. Okay, they have, a lot of processing power and the things happen, but it still takes time to come
Oh
back.
yeah.
It's not like an instant response. So, quantum computing, when that comes along, it's getting there. This is going to provide real time or near real time results for ML data. So
So
that's going to be huge, right?
well, so I'm on record. So for those who know me, I'm a physics and math nerd. So quantum computing, I've been watching it and studying it and following it since the 90s, probably before that. And I'm on record on 2 or 3 different podcasts, as well as some posts in LinkedIn, and saying that the killer app for quantum there's a lot of people talking about security, and they're talking about networking, and they're talking about all this stuff. But here's the reality: the best machine learning model driven chatbots are still clunky. You I have interacted with digital humans, and you're interacting with a digital human. The best ones in the world. Quantum will change that. Quantum will make it so that natural language processing that hears you, understands you, formulates the response, and responds will happen in milliseconds in a way that you won't understand that you're not talking to an AI.
Yeah. So it's a very interesting future. Watch the
Yeah.
space, ladies and
Yeah.
gentlemen. You heard it here
We-
first from our very own Sean G. Muller.
well, we need to have we have a couple quantum enthusiasts in Servian. We should probably drag one of them into one of the podcasts to talk quantum, and then you and I would both be on the side of we only know the surface level of quantum, and we would need somebody that deep math experience to be able to walk us through quantum. But yeah.
We got to watch those math nerds when they talk on podcasts, though.
Oh yes, very much so.
Doesn't always necessarily make a good podcast.
No. Well, Alistair, thank you very much for coming along on this journey with me on AI/ML. I hope it was interesting for you as well as the security was for me. I absolutely love talking through security with you. So I hope this was at least interesting and a little bit educational.
Yeah, definitely learned something. So thank you very much, Sean. That was great, and that's a wrap for this podcast. Thanks to all of you for listening in.
Yeah, absolutely. Alistair, where can people find you?
They can find me on LinkedIn, linkedin.com, and my profile is Alistair J. Ross. You can find me on YouTube. I have my own little YouTube channel, Al's Geek Lab, all one word. And you can find me on Twitter as well, AJ Ross NZ.
Yeah, don't you have a new episode of the documentary about to come out?
I do. It actually comes out on the 26th of February. It comes out on 26th of February, and it's about music, early digital music. So this is going back in time. So I've spent ages editing that one.
Are you going to talk Napster?
Oh no, this is even pre-Napster.
Even pre-Napster.
Pre-Napster. This is this module tracker music. This is all a special type of music which was the first sort of digital music before MP3s. So this is the thing that just happened just before MP3s.
Very nice. Well, so by the time this podcast lands, that will be live. So you need to if you need to go out and check it. If you would like to reach out to me, You can find me on the Twitters and the Instagrams and the Facebooks and the LinkedIns, Sean G. Muller. I will include links to several of the things that we talked about here in the podcast notes, as well as links to both Alistair and I's profiles and our email addresses. Reach out to us. Thank you as always.
Cheers.